And today I'm going to talk about a new type of information theoretic method of bidirectional estimation of partially black box layers of SOM-based convolutional neural networks. I'm Ryotaro Kamimura of Kumamoto Drone Technology and Development Foundation and IT Education Center of Tokai University in Japan. And this is the outline of my presentation. In the first place, I try to interpret the internal structure generated from multi-layer neural network, and interpretation is as independent as possible, and I try to compress multi-layered neural network into the simplest and non-hidden layered ones. However, we have a difficulty in model compression. By boxing those components, it becomes possible to apply the model compression to any types of networks. And we have just one application to show the good performance of the method. Multi-layered neural network have been applied to many application areas with good performance. However, as the complexity becomes larger, the interpretation of neural networks has become very serious. For application area with critical decision making such as medical and financial applications, it is absolutely necessary to understand the inference mechanism of neural networks. However, we have had many problems for the conventional method for interpretation. For example, the majority of methods are based on external methods such as symbolic rules and fuzzy rules for interpretation, and most methods aim to explain the responses of neural networks for some specific instances, and the majority of methods are based on the intuitive interpretation of data set, such as image data set. I think the interpretation by the external and local and intuitive method cannot be considered a real interpretation of neural networks. And today I primarily aim to interpret the weight themselves by self-compressing directly an original multi-layered neural network into the simplest one without hidden layers. In addition, all types of internal structure should be taken into account for interpretation. I try to interpret all aspects of neural networks. This is a model compression. We compress multi-layered neural networks to simple two-layered networks for interpretation, step by step, and all routes from input to output for compression are considered, and all variants by different initial condition architecture should be taken into account for the interpretation. However, some complicated components cannot be compressed. Those complicated components are temporary black box. The black box one can be estimated by the bidirectional estimation. Black box components are estimated in forward and backward ways. So today we have one application to the pulsar detection. We try to distinguish pulsar signal from non-pulsar ones. We have 20 by 20 neurons in the self-organizing map component. We have 3 conventional and 1 max pooling component. And CNN components are black box. We re-estimate CNN components bidirectionally. These output from some component, we could see clear differences between pulsar and non-pulsar. Pulsar 1 had strong outputs plotted on the upper side, while non-pulsar ones had strong output on the lower side, and some information can be expected to be of some use for detecting the pulsars. These are generalization errors. The lowest generalization error was obtained by the present method, The second best one was obtained by the banking method. The worst one was obtained by the logistic regression analysis. These are compressed and corrected weight. Before, we should see correlation coefficient between inputs and target as shown in the upper figure. And we have a corrective weight which are quite similar to the correlation coefficient as shown below. So we can see that we could see linear and independent relation between inputs and output by the present method. This is a comparison with other importance measure. The figures show the corrective weight by the simple neural network B, banking method C, logistic regression T, and mutual information E. All those methods produce importance measures different from the correlation coefficient. That means the present method could extract a very simple linear and independent relation with better generalization performance. This is a summary of my presentation. We tried to interpret internal structure for itself without any other method for interpretation. Interpretation is as independent as possible. All output from neural network are to be considered for corrective interpretation. And we compress multi-layer neural network into the simplest and non-hidden layered ones, and complicated component or black box for compression. And we have just one application to show the good performance. We could detect a linear and independent relation between input and output with better generalization performance. For future works, we need to generate different types of practical interpretation for specific purposes and instances from the internal structure, and we need to examine exact relation between SOM and SOM component, and we should apply the method to larger scale data set. Thank you very much indeed.